Object orientation, well, team developer has always been very good. I think some of you have been with SQL Windows team developer since it got introduced like 25 years ago, probably. We were missing a few of the things. So you basically organize your code in object classes that contain fields, functions that can represent real-world objects or functional areas in your applications. So basically you can create UDV objects, inherit those. You can create functional objects, inherit those. The main concepts of object orientation, encapsulation, inheritance, polymorphism, and team developer has been really good in all these areas, really. We have functional and GUI classes, so the functional classes are really very good. We have instance variables and instance functions. The inheritance is very good. Rich inheritance support, like multiple inheritance, which, for example, C# doesn't have, or .NET in general doesn't have, which we implemented in TD.NET as well. Late bound calls, function overriding. And in the past several releases, we added new features to make creating good object-oriented code even easier. So in 6.3, we added constructors and destructors. That was kind of a missing feature for quite some time, but now you can have your own constructors and destructors in your classes to initialize an object and to do work before it gets destroyed. You now have as well function overloads and protected function and variables in 7.0. So constructors and destructors. Essentially a function with no return type that is invoked whenever that class is instantiated. Why is this useful? You ensure your objects are fully set up. If your class requires certain fields be initialized or functions be called without a constructor, you leave it up to the caller to remember to do that. This leads to errors and more difficult to maintain code. So you have to document more, instruct your developers more, and these constructors are really useful for that. Help enforce a contract for your class. Perhaps you always need an ID passed to your class. Adding a non-default constructor which accepts an ID parameter, you force users of that class to always pass the data you need before they can get an instance. Default constructor, a constructor with no arguments, is always called by team developer when it auto-instantiates objects. If you want to prevent this, make sure you default your variables to object null when they are defined. So if you define an object in the local variables section, for example, and if you don't put that equals object null in there, then it will be initiated and the default constructor will be fired. So in 6.3 we added constructor and destructor nodes in the code. You can add one or more constructor node with variable argument count type. So the same thing that we added for functions is available for constructors. And the default constructor is the constructor that has no parameter, and the others can be called by yourself. And there's a single destructor node invoked when an object is removed from memory. So here's a little screenshot. You have a constructor customer here, which has a parameter, a number parameter that needs to be passed in. And you also have a default constructor here that has no parameters. So how to call constructors? So if you say my class call an object once, you define that object. This one is automatically instantiated and the default constructor is being called. If you do this one here, if you my class colon object 1 equals object null, then the constructor is not called, the object is left null, must use new operator to instantiate. So when you're in the code, then you do this set object 1 equals new my class, and you see that in the square brackets here you can using the parameters you can identify what constructor to use. Basically on the parameter signature it can tell what constructor to use. So constructors are fully functional, of course, in an inherent tree. So on all levels, the constructors will be called, and also the destructors, of course. So the destructors is like a constructor, essentially a function with no return type, runs when the object is destroyed, removed from memory, useful for cleaning up, close file handles, close database connections, null out references, but you shouldn't do anything big there, like starting new database connections, doing processing or something, because that can lead to problems. So there's a difference in the behavior between .NET and Win32 regarding destructors. In TD doesn't own memory management in .NET like on Win32, so we rely on .NET to clean up, do the memory management. So in .NET, the memory doesn't get cleaned up after a variable falls out of scope. It uses a lazy garbage collector that cleans up in background thread. This means the destructor can be called in unpredictable ways if no memory pressure might not be invoked at all until the application exits. So keep this in mind that you cannot totally rely on destructors being called on .NET right when you destroy the object. Function overloads, another area that has been enhanced in the 7.0. So create several functions with the same name, only differing by argument count or argument type. So basically the same thing as with the default constructor and other constructors, where you have different parameter signatures. Not necessarily a feature for object-oriented design, but something supported by most languages. Makes code cleaner. You can have several versions accepting different parameters without having to use unique names. We will look at this in an example. So I think that makes it clearer when you see the code. You can have a show text function that has a string parameter. You can have a show text function that has a number parameter, or a show text function that has a string and a number parameter. And depending on what you pass into the function, team developer will execute the right function. And in some cases, it actually needs to guess. And I think there's a function overloads applies to internal functions, class functions, window functions. Duplicate function names allowed for a given scope, provided parameter types are different. UDV type parameters supported. Late bound function attempt parameter match. Runtime errors are possible. That's clear. So template names passed to overlap functions may have multiple types that match. So you could have something like this: show control string, window handle, show control string, df1, and it's not clear, what you would you use this as a window handle, or would you interpret this as a string? In this case, it would be interpreted as a string, and in this case as a number, and in this one, in a form window name, it would be interpreted as a window handle. See, so there are some areas where it's not so clear what would be used. This is the guideline to that. So controls with values such as data field, list box, preferred match to control data type, backup match to window handle parameter. So the ambiguity, show control string, window handle, or window handles string, and then you do this here. See, the definition here is the definition is still all right. This looks good, but then here, what to do with this, right? This one or this one? So what we do is we give preference to the native data type over the handle and left to right order. So it can be quite complex. So basically, you can create a number of functions to your developers that provide the functionality you might need. So depending on what kind of connection you do, for example, you can provide additional data for that function or not. So it's just a sample. So in TD, when you are coding, Active Coding Assistant and this coding assistant here, both support this. They will show you the different function names and the different the same function name with a different parameter signature. So you can choose from the definition here and choose what to call here at this position. So another new feature are the protected functions and variables. In most programming languages, you can restrict access to members, variables, and functions and classes. It's an important object-oriented design principle to enable proper encapsulation, so your developers won't call things that they are really not allowed to call from a position. You don't want to encourage developers to directly access certain variables or functions, as they might not fully understand how they should be used. So basically you get clean interfaces and easy to understand how to call your class functions. So there was a method to do that using double underscore. It's kind of a pain, but here's how that works in TD7. Basically, if you are in a class, you can then go to the on a function in that class, and you choose add next level protected function, and then the code coming out is like this. Below the function, you get a protected function, and you can set it to yes and no. And the same is true for instance variables. You go onto that variable, add next level, set it to protected variable, and then you can again switch to yes and no here. And the Active Coding Assistant also filters out private members depending on scope. So that's all built into the system, so you won't even be offered protected variables if you're not allowed to. Why useful? Encapsulation, prevent access from outside, force access via methods. So you could get better code for large projects with multiple developers, helps prevent mistakes where incorrect variable access or function usage by another developer. And let me show you a sample for that. We've got some other samples. So, constructor, destructor. We go into the classes. Constructor, destructor. Constructor class A. So that's basically the constructors are calling, putting text into a message box, basically. There's a destructor class A. So this text will appear in a message box. There's a class B. I think class A is not derived from anything. Class B is derived from class A. It's got constructor class B, which is a default constructor. And class C is derived from class. So it's got multiple inheritance here, class A and class B. And you've got a local constructor as well. So let's run this. So basically, if I create class R, then the constructor of class R is being executed. If I create class B, A and B is the constructors of A and B are executed because B is inherited from A, and for create C, you get 2 times A because it's inherited from A, from B, and B is inherited from A, 1 from B and 1 from C. And then you can also destroy them, and you see those are called as well. Function overloads. I have classes here. So there are 3 show text functions, each with a different signature. So a string, a number, and a window handle. See what this does. So calling with string parameter, so form class with string parameter, calling with number parameter, calling with handle, and other buttons. See here, show text with string. Show text with number. Yeah. And then I think I've prepared this one here. Protected class 2. You see here instance variables. One is set to protected yes, and another one is set to protected no. You don't actually, for no you wouldn't need that, but you can have that there. No, here's nothing. So in Windows there was something, message actions, onsend create. So now, outside the scope of the class, if I want to set UDV1 dot, then you see the active coding assistant just shows the public one, not the private one. So let's have a look at this one here. Priv var set UDV1 dot priv var equals something, and if I compile that now, it should really complain. See, protected variable not allowed in this context. So the coding assistant doesn't even show it to you, but if you type it in yourself, then the compiler will complain. Okay. Questions regarding the object-oriented features?